for 5-17a, you had both your graph of the original equation and the inverse graphed on one coordinate grid. Your job was to draw in the line of symmetry. So remember, a line of symmetry would be if we folded our graph along this line, they would match up and lie perfectly on top of each other. So on my graph here in red, I have f of x, which is our original equation. In blue, I have the inverse of our equation here. And then in green is my line of symmetry. So for part B, we want to write an equation for our line of symmetry. And I'm going to use our slope-intercept form. So if we take a look at this green line here, we are going to have a y-intercept of 0 because this point is going directly through 0, 0. So I know that we will have plus 0 out here. Okay. My slope, if I go up 1 over 1, up 1 over 1, my slope is 1. So I have 1x plus 0. If I simplify this all the way, I end up with y equals x. It's 1 times x and then plus 0. So this is the equation for the line of symmetry. That means whenever we are creating an inverse, we flip it over this line. Now, if we look at this, it makes sense, right? So for example, if I would take this point 0, 3. So let's say I have 0, 3. This is my x, this is my y. Well, according to our equation, when we take the inverse, my y becomes my x becomes my y. So the new ordered pair would be 3, 0 on my inverse line. So let's take a look at my blue inverse line right here. And sure enough, that point that would mirror across is 3, 0. So whenever we have the inverse, just like in our tables, we're flipping the x and y. Same goes for a graph here. We flip the x and y. So if 0, 3 was my original, 3, 0 would be my inverse. Another one here, I have 4, 5 on my original. 5, 4 is going to be the point. Oops, if I can get close to it. 5, 4 is going to be the point on my inverse.